that why cloud is required nowadays. Okay, and nowadays without cloud computing you can't do anything because huge amount of data is generated, a lot of storage and processing units are required, and which is not feasible for one standalone system, laptop or a desktop. So we require service providers. Okay, we'll and we pay them for the services that we avail from the vendors. Okay, so this is what we have discussed as far as cloud computing is concerned, and we have talked about three different uh, deployment techniques, that software as a service, then platform as a service, then infrastructure as a service. And then when I say software as a service means you have the data but you don't have any software. So you hire software from the third party vendor, use it, okay, through internet connectivity. So the data will be stored in their servers. Okay, something like you're ordering uh, any food stuff or any pizza and all through Zomato or Swiggy, and they'll just uh, send you at your doorstep. Okay, you are not going to the restaurant. So that is something called software as a service. Now if we talk about platform as a service, and last class I have probably given an example that rather than ordering through online using Swiggy or Zomato mobile apps, you can directly go to the restaurant, use their infrastructure like tables, ambience, AC and all. Okay, but the food they'll serve. Okay, so that is nothing but platform as a service. So what is a platform here? The ambience, the table, chairs of the restaurant that you are using. Okay. And the third one, when I say platform as a service, it is generally for developers. Okay, so the developers require hardware, software tools, so they are hired from the cloud service providers. Okay, they develop their application by using the tools, whether it's a hardware tool or software tool from the third party. Okay, so if you talk about software as a service, then we are the users and the clients. They comes under that category where we use the softwares of the third party. If you take platform as a service, then developers are the key people here, because they develop products, and for that they hire from the cloud service providers the tools and the hardware that they require for their product development. Similarly, if you talk about infrastructure as a service, okay, so if you just scale up this example of going to the restaurant and having a food. So you go to the restaurant, and rather than having their food, you start cooking food on your own by using their resources. Okay, so their resources means their utensils, their gas, their all raw stuff that is actually required for cooking. So you start using them. Okay, so that is nothing but a sort of what you call infrastructure as a service. And here, all the network, the storage, the virtualization all comes under infrastructure as a service. And who are the users here? The network administrator, database administrator, system administrator. So they are the people who use this. Okay. So today I'll discuss the concept of virtualization. Okay. And then last class probably I mentioned three different categories of clouds, like public cloud, private cloud, and the combination of both public and private, that is called hybrid cloud. Okay. So when I talk about virtualization, let me say, draw the example what virtualization actually means. So as I mentioned in the previous class also, cloud is nothing but a computer itself, but that is not your computer. There's a computer from some third party, so that you're using. Okay, so why you're using others computer? Because your computer is not sufficient enough to run your application. Okay, the resources are limited. Okay, so you want the third party should provide you the services for running your applications. Okay, so for instance, why this virtualization is very much important in case of cloud computing. So this is my server. Server is itself is a computer. Okay, now in general, what is there inside the computer? I have got RAM, I have got ROM, I have got processor or CPU, or you call it as a processors. So we have different like dual core processor. Yes. So processors, network. Okay. So all this is there in our one standalone machine. Now what you do, you create multiple instances of these things here in a form of VM. Okay, so when I say VM is a virtual machine consisting of many RAMs, many ROMs, many processors and many networks. Okay, so one VM may have many instances of this particular machine. Okay, so like this you create several virtual machine on one computer system itself. Okay, and who is going to manage these many virtual machines you have created? So that is nothing but what you call hypervisor. Why this noise is coming? Who is there? Okay, so this is what I have got the resources of one machine. I'll create plenty of such resources as a virtual machine on this another system called server. Okay, and who are going to monitor so many instances of machines that you have created? So there is a program or a software called hypervisor. Okay, so one such hypervisor is VirtualBox. Okay, VirtualBox is an open source. You can Google it. Okay, so you use this VirtualBox as a hypervisor to install other softwares, other operating systems that are not there in your desktop or a laptop. Okay, so this concept is called as virtualization. Okay, several instances of one machine you are creating in another machine, and that machine is called as a server, and all these are nothing but guest machines, and this is called as a host machine. So this is a host where you have created several instances of virtual machines. Okay, so this may be an instance of Ubuntu, this may be a Linux, this may be a Solaris. So it depends on how you're going to create instances. Okay, so what you are doing here, you have got only one system here, and on that you have created multiple operating systems. Okay, and these operating system based, and because this have a hypervisor or a software, it runs several algorithms, scheduling algorithms. Okay, so which virtual machine will share which resource that are available in this particular server, because this server have got some dual core processors, RAM, ROM. Okay, all these will be shared by these multiple instances or the operating systems that you have installed here. Okay, so I've got only one such resource here, maybe a CPU resource or dual core processor or a RAM or a ROM, a hard disk. All this will be shared by this multiple instances of virtual machines that you have created. How they are going to share it? So it is the job of supervisor. So that is nothing but hypervisor. So hypervisor's job is to monitor these instances that you have created as far as sharing the underlying resources of this server is concerned. So one such hypervisor is VirtualBox. We have plenty are there. One is Scan. Okay, so we generally use VirtualBox. Okay, so this is what about virtualization is. You are creating a virtual machine on one particular system, and all these virtual machines are going to share the resources, the underlying resources that you have. Okay, and the sharing is, and the monitoring, sharing, everything is done by the hypervisor. Okay, so that is what this says. So virtualization is the ability to run multiple operating systems on a single physical system. So I have shown multiple operating systems and multiple instances of the virtual machines that you have created on a single physical system. Okay, and share the underlying hardware resources. So this is very important. Okay, share the, so this is share the underlying hardware resources. Okay, so this is from one of the important company we have called VMware. Okay, so from there they have given the definition that multiple operating systems are shared on a single physical system. Okay, so this is what hypervisor. Okay, so that is what you call virtualization platform. Okay, so multiple virtual systems can run on a single physical system. Okay, so as I mentioned, that hypervisor is nothing but a software or a program that is going to monitor. So we call it as VMM, so virtual machine manager or a monitor, or virtualization manager is a program that allows multiple operating systems to share a single hardware host. Okay, so this is from the definition. So each guest operating system, what it does, it appears to have the host, processor, memory, and other resources all to itself. Okay, so each and every instance of virtual machine will feel like they have got their own individual hardware, storage, and everything, but it's not like that. They are sharing. There is only one. Uh, there is only one processor or a dual core processor of one machine. There is a hard disk, there is a ROM, there is a network. All this belongs to one particular system only. So on that we have multiple virtual machines or same operating system with several instances or different operating system. Okay, so each guest operating system on these machines, on this single machine, can have a feeling that they have got their own underlying hardware and software. This machine has got its own underlying hardware and software. This machine has got its own underlying hardware and software. But in reality, there is only one system beneath it, the physical system, having the processor, memory, RAM, whatever it is. Okay, so that's why they say that each guest operating system appears to have host, processor, memory, and other resources all to itself. Okay, so that is what everything is virtual. Okay, however, the hypervisor is actually controlling the host, processor, and resources, allocating what is needed to each operating system, in turn taking sure that the guest operating system called the virtual machines cannot disrupt each other. Okay, so each and every virtual machine will get the responsibility of sharing this resource, and how the allocation of the resources to these virtual machines will take place. So that will be handled by the hypervisor by using various resource allocation algorithms. Okay. So what are the benefits of this virtualization? Having multiple machines with multiple applications running on the same one physical system. That is, sharing of resources helps cost reduction. Okay, rather than having, because every virtual machine doesn't have a different hardware and a software capability. Otherwise, a lot of cost will be involved. Okay, so I have only one physical system on which I have created several instances, the virtual instances of virtual machines. Okay, so virtual machines are isolated from each other as they are physically separated. Virtual machines encapsulate a complete computing environment, sharing the system resources. Virtual machines run independently of underlying hardware, and they can be migrated between different hosts as well. Okay. So cloud computing takes virtualization one step further, and you don't need to own the hardware. Okay, because whatever the system hardware is there, that will be shared by all the VMs. Okay, so no need to invest huge amount of money to install different hardwares or softwares. So resources are rented as needed from a cloud. Various providers allow creating virtual servers. Okay, so choose the operating system and software each instance will have. I'll show in AWS how these instances are created. So the chosen operating system will run on the large server farm. Okay, and can instantiate more virtual servers or shut down existing ones within minutes. Okay, so if you have multiple virtual machines and several operating systems running several applications, all these will be controlled by the underlying hypervisor or a software. Okay, so here also, so we are availing the services from the third party, so you have to pay for that. Okay, so you get billed only for what you used. Okay, this you leave it. Okay, this is not required. I'll just tell the basics only. So this is what I mentioned, that virtualization is a technique of how to separate services from the underlying physical delivery of that service. Okay, and it is a process of creating virtual version. So different virtual versions of virtual machines we are creating of something like a computer hardware, and it is initially developed during the mainframe era. Okay, so in the earlier we have one particular mainframe or one large system, and different thin clients will be there. So thin clients doesn't have any resources. They'll use all the resources from the mainframe. Okay, it will look like this. In the earlier system, they use this mainframe. Okay, so mainframe itself is a large machine consisting of several resources, and it will be connected to different types of clients. We call it as a thin client. Okay, and these thin client, they'll have a monitor and the connectivity with this. They don't have any own processor or resources or storage devices. So everything will be there in this mainframe itself, and they'll keep on sharing this. Okay, so it involves using specialized software to create a virtual or a software created version of a computing resource rather than actual version of the same resource. Okay. So with the help of virtualization, you can have multiple operating systems. You can run multiple applications on the same machine. Okay. So and it's same hardware at same time, increasing the utilization and flexibility of the hardware. Okay. So in other words, one of the main cost effective hardware reducing, because for every virtual machine you are not establishing your own hardware resources. Okay. So cost is minimized, cost effective, and energy saving techniques used by cloud providers is virtualization. Okay, because once you have got virtualization, because one processor you have to handle rather than several processors for several VMwares. Okay, so virtualization allows you to share a single physical instance of a resource or an application among multiple customers and organizations at one time. Okay, so because you have got only, so when I say single physical instance, I'll show in the example of Amazon Web Services that EC2. Okay, so EC2 provides several instances of different types of operating system. You can choose any one, and then you can create several instances of that, and you can run multiple applications. Okay, so that is what it is mentioned, that it allows you to share single physical instances of resources maybe provided by AWS or an application among multiple customers and organization at one time. So it does this by assigning a logical name to a physical storage and providing a pointer to the physical resource on demand. Okay, so when you create an instance, you'll get an IP address. Okay, so that is nothing but your logical name to a physical storage and provides a pointer to that physical resource on demand. Okay, I'll show how EC2 is created. EC2 is used in AWS as well as S3 also. Okay, so I have EC2 from AWS, similarly S3. Okay, so simple storage service. Okay, so I'll show you in the AWS what are the different services AWS gives to their clients. Okay, so and those services belong to different domains. We have IoT, we have cloud, we have IoT, cloud computing, blockchain, machine learning. We have different domains, and we have different types of services that can be used. So the term virtualization is often synonymous with hardware virtualization, which plays a fundamental role in efficiently delivering. So that is what we call comes under infrastructure as a service. So when we have talked about IaaS, PaaS, and SaaS, in this I have mentioned network, storage, and virtualization. Okay, so here also it is coming infrastructure as a service solutions for cloud computing through virtualization. Okay, so virtualization technologies provide a virtual environment for not only executing application but also for storage, memory, and networking. That is what I mentioned here. Okay, so all this comes under infrastructure as a service. So benefits already I have discussed. So more flexibility and efficient allocation of the resources. So you can create multiple instances. Okay, and you will pay depending on the usage of those instances. Okay, so those virtual machines or the operating systems that you create. So when you use it, then only you will get the bill. Okay, so enhanced development productivity. Okay, you can create multiple instances for your multiple applications. Low cost is involved. So remote access and rapid scalability, you can create depending on the application. You can increase the size of the compute devices. You can add more instances. So it will be available 24/7. Okay, whenever it is required, it is available. If one instance is lost, then other instances will take care. Okay. So pay per use of the IT infrastructure on demand. So okay, whenever it is required, then you can use it. So enables running multiple operating systems. So that is what we have already discussed. So different types of virtualizations we have: application networks, desktop, and storage. Okay, so before this, let me show you about AWS. So I'll tell you how to create an instance, and so I request you to all please create an account in AWS. Okay, so they'll ask you to ask your debit card details, you enter. No need to panic, no need to get panicked there. So they'll deduct ₹2 and they'll return it also. Okay, just for security purpose. So imagine Elastic Compute Cloud, or what you call EC2. Okay, the full form is Elastic Compute Cloud. Why it is elastic? Because you can scale it up to different number of instances, 2 to 4, 7, 8, depending on the application. Okay, so like a rubber band, it will be you can elongate it. Okay, depending on the need. So that is what it is called Elastic Compute Cloud. Okay, you can increase the size. You can, okay, depending on the application. So we have AMI called Amazon Machine Images are the basic building blocks of Amazon EC2. Okay, these AMI images are nothing but the operating systems only. Okay, I'll show you. So for the time being, the EC2 is nothing but Elastic Compute Cloud provided by the Amazon, and the AMI are the basic building blocks of EC2. So AMI is a template that contains a software configuration. Okay, so what is that software consist? Operating system, application server, and applications that can run on Amazon's computing environment. Because the Amazon is a service provider, they will provide you the operating system and all the hardware on which it is going to run. Okay, you can run your application. So AMI is a template that contains a software configuration. What is there inside it? Operating system, application server, and other applications that can run on Amazon's computing environment. So AMIs can be used to launch an instance. I'll show how to launch an instance. Okay, so when you launch an instance means you're creating a virtual machine. Okay, so which is a copy of AMI running as a virtual server in the cloud. Okay, so I'll show the list of the operating systems that AWS has, and you create an instance. You can create several instances of the same operating system. Okay, or you can create multiple instances of multiple operating system. Okay, so that is what you call AMIs can be used to launch an instance, but that instance is nothing but a copy of AMI running as a virtual server in the cloud. Okay. So these are steps that we'll follow now. You sign up for Amazon EC2. So you must have an account in AWS. You create an account. Then rest of the steps I'll explain uh, by showing you practically. So you can create a key pair, launch an Amazon EC2 instance, connect to the instance. You can customize the instances. You can terminate instance and delete the volume created. So once you create an operating system, you can stop it. You can reboot it. Okay, whenever it is required. So creating a key pair is generally for security purpose. It uses public key cryptography to encrypt and decrypt login information. So you once you create an instance, the instance is created from your login, so it will be encrypted for security reasons. Okay, so we have a public key cryptography to encrypt and decrypt your login information. So AWS only stores the public key and the user stores the private key. Okay, so that is what we call key pair, public key and private key. Okay, public key is known to everyone, so private key is yours. Okay, so AWS only stores the public key and the user stores the private key to match. So there are two options for creating a key pair. Have Amazon EC2 generate it for you. Okay, it will generate on your own, or generate it yourself using a third-party tool such as OpenSSH. Okay, then import the public key to the Amazon EC2. Okay. So this is how it looks. Let me show you. So this is what Amazon EC2. So you can write www.amazon.com. You can Google it. You will get. So this Amazon Elastic Compute Cloud provides a scalable computing capacity in the Amazon Web Services Cloud. So Amazon Web Services is your vendor who is going to provide you these services of creating instances or the operating systems. So using EC2 eliminates your need to invest in hardware and upfront because you are not investing money in establishing your own data centers or hardware upfront. So you can develop and deploy applications faster, and you can use Amazon EC2 to launch as many or as few virtual servers as you need, depending on the application. Configure security and networking and manage storage. Okay, all this is handled by Amazon. It enables you to scale up, okay, or down to handle changes in the requirements or spikes in popularity, reducing your need to forecast traffic. So a lot of things you can do once you create the instance. So this virtual computing environment or the virtual machines are nothing but they are called as instances. Okay, and these instances are created through AMI or Amazon Machine Images. That is nothing but a package, the package, the bits you need for your server, including your OS and additional software. Because once you create a virtual machine, it requires operating system, and the operating system is going to run on a particular hardware. Okay. So various configuration of CPU, memory, storage, networking capacity for your instances known as instance types. Okay. Because once you create a virtual machine, it must have all this. Okay. And all this will be from Amazon itself. So secure login information for your instance. For secure login, you have a key pair, public and private key. Okay. So then persistent storage volumes for your data using Amazon Elastic Block Store, what we call EBS, known as Amazon EBS volumes. So volumes is nothing but because once you create such an instance, you might be running large applications where huge amount of space is required. Okay. So static IP4 and all this you can study on your own. So let me jump into how to create the instance. Okay. So this is a uh, let me start from the beginning. Okay, so I have already logged in. So you have to log into AWS management console. Okay. So you can in Google you can type directly AWS management console. Okay. So before that you have to create an account. Here I have created an account. Okay. So this is my ID. Okay. So I have created an account, and here, as I mentioned, that you'll find different type all the names of the countries or the continents where we have got the Amazon data center, and only one you have to choose is Ireland, this one, because it is free. Rest they'll charge you huge amount of money. Okay, so you choose Ireland. So here you see I have chosen Ireland. Okay. So this is how it will look like. Okay, and now you so this is you in the top right hand side you will find left hand side you will find services. In these services you can type directly EC2. Okay, sorry, EC2. So here you'll get EC2. Okay, virtual servers in the cloud. You click it. Okay. So now here you see. So we have got the EC2 dashboard. So now here you see all other configurations, instances, instance type, launch templates, bot request, saving plans. Okay. So to get started, launch an Amazon EC2 instance, which is a virtual server in the cloud. So this is what we have discussed so far as far as virtualization is concerned. So you have to create a guest operating system. Okay. So that's nothing but your VM. So this is here, launch an Amazon EC2 instance, which is a virtual server in the cloud. Okay. So let me launch an instance. All this is possible once you create your own account. Okay. So choose an Amazon machine image, AMI. So an AMI is what? Is a template that contains the software configuration. Okay. So because once you're creating an instance means you are not only installing your operating system, but the corresponding hardware also. Okay. Operating system, application server, and applications required to launch your instance. So you can select an AMI provided by AWS. Okay. So here you see Amazon Linux to AMI. Okay. So this is the AMI. So it is free tier eligible. Now you can create an instance for this. You can select this. Okay, but I'll go for Ubuntu. See Red Hat Enterprise Linux, Amazon Linux AMI. So what I'll do, I'll create an instance of this. Okay, because most of us use Ubuntu here. So Ubuntu Server 20 version. Okay. So here it is free tier. So you are eligible for that. So let us 64-bit. Let us select this. So now here it is creating the instances. Okay. Now you see. So Amazon EC2 provides a wide selection of instance types optimized to fit different use cases. You will find different configurations of this. See that Ubuntu server is how many configurations we have. Okay, so from gigabyte, 100 gigabyte, 25 gigabyte, how much you require. Okay, so Amazon EC2 provides a wide selection of instance types optimized to fit different use cases. So different applications, you require different types of instances. These instances are virtual servers that can run applications because you don't have the required capability or resources for your application on your to run on your laptop. So you require services provided by the Amazon. So you create a virtual server. So instances are virtual servers that can run applications. Okay, because once you create an instance, why you create an instance, why you want an operating system, because you want to run an application which won't run in your normal laptop. Okay, so they have varying combination of CPU, memory, storage, networking capacity, all this is nothing but EMI. Okay, Amazon machine image, and give you the flexibility to choose the appropriate mix of resources for your applications. Okay, so here you see so many families are there. Current generation. Okay, now here you see type 2 micro. So T2 instance provides baseline level of CPU performance with the ability to burst above the baseline, and the baseline and the ability to burst are governed by some CPU credits. T2.micro receives CPU credits continuously at a rate of 6 CPU credits per hour. And to learn more about, you can see this. Okay, so what by default it is selected a free one. Okay, so one instance of CPU, memory gigabyte, 1 gigabyte. Okay, so instance storage is EBS only. Okay, and IPv6 is supported. Network performance is low to moderate. Okay, you can see here configuration instance details. If you click here, you can see the configuration instance details. Okay, so you see here, configure the instance to suit your requirements. You can launch multiple instances from the same AMI. Okay, one AMI I have shown you, that free one. So from there you can create multiple instances. So request spot instances to advantage of lower pricing, assigning and access management. So number of instances is 1. Okay, so now you can scale up. You can increase this size. Okay, we call it as auto scaling. So auto scaling means depending on the application, it will scale your instances. So this is VPC subnet. Okay, all that is given. Okay, no need to change anything. Okay, all this is given. Okay, so you click here the button review and launch. Okay, now you see here Ubuntu server of version 20. Okay, so EBS general purpose, SSD volume, all this is a configuration. Okay, so instance type is T2 micro. Okay, so 1 gigabyte. Okay, launch wizard 7 description it is given. Okay, you can see the instance details. You can click here, see instance detail. Okay, so there's a network ID. Number of instances is 1. If you see the storage, so there's a details about the storage. Okay, so 8 gigabyte maximum it goes. Okay, so tags is also there. Okay, so tag is nothing but the key pair that we generate. Okay, so now let us launch this. So when you launch, it will ask you to create a key pair for security purpose. So a key pair consisting of a public key that AWS stores and a private key file that you store. Okay, so that's it is key pair. So public key it is open and private key is yours. Okay, when this key pair is entered, then only the operating system will be activated. Otherwise, if this is shared with others, then other will use the resources and you have to pay the bill for that. Okay, so together that they allow you to connect to your instance securely. This is only for security purposes. This public key cryptography is done. So there are key pairs are there, public and private. So for Windows AMIs, the private key file is required to obtain the password used to log into your instance. For Linux, the private key files allows you to secure SSH into your instance. Okay. So the selected key pair will be added to the set of key authorized for this instance. Okay. So let us create a new key pair. Okay. And let this name is basics of intelligent computing. This is my key pair. Okay. So you can download this key pair. So it will show .pem extension. It will just an encryption file, RSA encryption. I'll show you. So that is .pem file. Where it went. I think it is stored somewhere. Okay, I'll show you. It can be opened through Notepad. So I've created a key pair called BIC. Okay, you can download it. So now in the bottom you see launch instances. Okay, so you have to download the private key file. So that I've downloaded. Okay, so that will come as bic.pem. Okay, now you launch the instances. Now I'll create a virtual server for you, the Ubuntu server. Okay, so your instances are now launching. Okay. Okay, so here all the details of your launch. The following instance launches have been initiated. So there's the ID. So get notified of estimated charges. This is not required now. Now if you at the bottom you see view instances, or you click here also you can see that instances. Okay, let's see view instances. So this is what there's a second instance I have created. The first one is stopped. Okay, so welcome to the new instances. Okay, we are redesigning the EC2 console to make it easier to use. Okay, so there's a Amazon message. See here what is there. I have got the new instance I have created. There's an instance ID. Okay, so instance type initializing, availability zone, so IP address of that instance that you have created. Okay, launch time, everything is there. Okay, so now let us click this. So you see here now the instance is ready. Okay, so IPv4 address is given. So there's a private address, it is there, and there's a public. Okay, now it is running. Okay, all the details you will find here. Okay, Ubuntu, so Amazon machine image. Okay, so this is nothing but the entire operating system, the image file. Okay, so all the details are there. Let us connect now. So I have created a launch. I have launched an instance. Okay, now I'll try to connect that. So here you see connect. So this is my instance ID. So there are various options are there. You can start using the stop the operating system, you reboot, you can terminate. Okay. So now it is running. So I have to open this. Just go back this. So all this is before launching this, you must have an account. To instance. Okay. So here you see the operating system is now ready to execute your applications. So you'll get the entire Ubuntu interface here. See here, this one. Okay. So sudo apt so here is actually not required because this. So this you are getting a Linux environment or Ubuntu environment. Okay, so you can execute your applications. Okay, you can install Python. You can install any other software. Okay, so the meaning is that your instance, your operating system is ready here. Okay, so like this, you can create your own instance. You can create multiple such instances. Okay. Version. Python is there, I think. Install pydh. So you can check several applications you can run on this operating system, and you can create many such instances. Okay. So this is how you can create the instances. Okay. So if you have any doubt, you can ask me. So there's one such example that I've shown, and similarly, let me stop this. Okay. So it's loading the instances. Now you can stop the instance here. If you won't stop, then you can get the bills even if you're not, because if you're using, then only you can pay for that. Okay. So now it is successfully stopped. If you want to start the instance, then you can start instance. Okay. So like this, you can create multiple instances. Okay. And you can run the application. So this is what about virtualization. Okay, you don't have anything in your laptop and you're using the operating system provided by the Amazon on your machine. So it'll give a feel like you have got their Ubuntu installed on your machine or any other Red Hat Linux or Windows Server, whatever it is. Okay, the list of instances I have shown. Okay. So similarly, we have another called S3. So S3 is scalable storage in the cloud. Okay, so this we'll discuss tomorrow. So far, I have shown the computing. Okay, elastic computing, because in order to run any application, you require an operating system. So that is nothing but a compute. Now we talk about storage. Okay, tomorrow we'll discuss this. Meanwhile, I'll show. So as I mentioned that the different services that the Amazon actually provides, they are belonging to different domains. So this is what one that we are used in compute, and there are several others are available for storage. Okay, so S3 stands for simple storage and service. Okay, similarly, if you want to work on robotics, blockchain, quantum technologies, machine learning, augmented and virtual reality, then see all these are different domains. Database, end user computing, business application, analytics, all are different domains. IoT, game development, developer tools. So we have an Amazon developer console also. Okay, as I mentioned that in platform as a service, the developers require some software and hardware tools that they can't purchase and they are very expensive. Then they get use from the Amazon service with minimal cost. Okay, so you see here code star, code commit, code deploy, all these services are there. So all are from different domains. Okay, so I generally use this IoT core. So hope you understood. First, you have to create an account. Okay, so you have to create an account. console.aws.amazon.com. So there is a URL console.aws.amazon.com. So there you create an account. Okay, so then you can access all this. You can try out how to create a instance and all. Okay, so if you have any doubt, you can ask me. So like this, once you create an instance, you'll get all this account setting. So make sure that once you create an instance, you stop it. Okay. So if anybody having any doubt, the S3 we will discuss tomorrow. Okay, so these are general idea about AWS. There are so many services are there. Okay, so depending on the application, you have to choose any one service. So how to get an operating system through instances that I've shown. Similarly, tomorrow we'll discuss how to create storage space where you can store your own files in the cloud. Okay, because your machine doesn't have that much storage for you. You can you can have plenty of movies and videos and all. You can dump there in your Amazon storage S3. Okay. So many of you have got some queries as far as the pattern of the quiz 3 is concerned. The quiz 3 consisting of both objective as well as subjective. So you have to ready for both. Okay. Because neural network means you have to solve something. Okay. So you use calculator and solve and get the answer and upload that. So I'll put both categories. Okay. Objective as well as subjective. Generally, I'll try to put objective only, but you have to solve. So anybody having any queries? So are you getting what I'm teaching? These are all some basics. These are all very basic things that are very many people might be knowing all this. Okay, but many of you may not be aware of this. But nowadays, everybody knows about cloud, because without cloud we can't do anything. Because even if you're ordering anything like from Swiggy and all, they're all using cloud computing itself. So we'll stop here. Tomorrow we'll discuss about other services because it's not possible to explore all the services. I would have taught you how to use this IoT core, but that is not required. That'll take plenty of time. Okay, but S3 I'll tell you how to, because it will take hardly 10 minutes to explain S3. Because what is more important is you just try to create your own account. Okay. So today we'll stop. Okay. Thank you. Tomorrow we'll meet. Okay. Bye bye.